Okay, so to create this displaced geometry, the first thing that we need to do is create a mask for wherever the rock is on the surface. Now, we did create a bedrock mask using the erosion nodes, but unfortunately, the bedrock mask doesn't quite do what we want it to do. So if I drop down a new attribute VOP and go inside, we can drop down a bind node and bring in the bedrock attribute which we created. So if we type it in bedrock and we plug this into color, we can see what we get. Now, let me just explain a little bit about what just happened there, just for anyone who is perhaps not as familiar as they would like to be with this process. So, when we look at a mesh, each point on that mesh has a certain number of attributes assigned to it. So, if I go back to this guy here and I middle click, oh, it's just popping up off screen. Let me just bring it up here, show node information. We can see that we have a lot of information assigned to this geometry, but this is also assigned to every point on that geometry. So if I go to the geometry spreadsheet, which is where we find this information, we can see everything that's attached to it. So we have the points, the vertices, the primitives and the detail attributes assigned to this geometry. So if we go to the points, for instance, we have the position in X, Y and Z of every single point. The alpha, the bedrock, this is one that we created within the erosion node. The color assigned, cliffs, debris, etc. So what this means is we can also manipulate and update these attributes whenever we like. And one way to do this is using the attribute VOP. So if we jump back inside, we can bring in the bedrock attribute and see what it looks like in the viewport by assigning it to the color output, which is what we have here. Now, as we mentioned, unfortunately, this is unusable because it doesn't give us what we want. Where I would like to use the bedrock is on the surfaces that are flat and vertical and perhaps maybe interspersed throughout the terrain itself. But what we have at the moment is this just completely white object with some black values at the base. So instead of using this, we will create our own. To do this, we need first the normals. So if we, for instance, take the n value here, which is the normals assigned to this geometry, we can see what this looks like when we plug it straight into the color. So now we have the normals connected. We actually don't need all of this information. We just need one channel. So again, we will use a vector to float. And we will isolate just the green value here. And we will use a fit range to clamp this and invert it too. So add in the fit range and we'll clamp this up a bit. Let me just put this back to smooth shaded. And invert it. Cool. So what the fit range does is you can imagine it kind of like the levels function within Photoshop. So we have the contrast at the top, which is changing the source minimal and the source maximum, and the destination min and max, which you can think of as the clipping. So we can clip the blacks to be above 1, or the whites to be below 1, or we can flip it and invert the whole thing here. Awesome. So this gets us the direction, but at the moment we don't really have a lot of exciting information. We just have a whole bunch of white and black spots. So let's play with this a little bit. The first thing I want to do is try and introduce a little bit more interest in the noise. So I'll drop down an anti-aliased noise, and that's just a bit of a higher quality noise. If I plug this into the color, just so you can see what it does, and I'll also plug in the position because that's what this node requires, as you can see here at the top, and take down the frequency. Now, because we work in world space, 1 is actually 1 meter, so it's pretty small. So we need it much bigger. Much lower frequency, should I say. So there we go. If we set this to a value that's more along one axis than the other, we can stretch it along it. So if I set this to something like minus, and I'm dialing in these values because these are the values that I used previously. What we start to get is some interesting information that is indicative of the type of build-up or variation that we see when we get the sediments revealed on the sides of mountains. So if we use this to create the rock and generate the rock, then we will get some information that is representative of the type of striations that you see on some mountains. It also adds a little bit of order to what can sometimes be quite a chaotic process. So we can add these two guys together, drop down an add node, and an add just does what it says. It just takes one value and adds it to another. And we'll plug this in. Awesome. I will drop down another fit range just to make sure that these two values are working well together. That's fine. Now, another thing I would like to do is to break up some of this noise, as we are getting these long lines without any imperfections, and there are ways that we can add some more rocky type shapes to break this up. So one of the noises that we will use quite often is the Voronoi noise. So let's type that in, Voronoi noise. And we have a few options here, but rather than telling you what they do, it's much easier to show you. So we'll plug in a position again. We will put down a subtract and subtract 1 from 2. So and plug this in. It's of course too big, so we'll take that down. So you can see what we get with the Voronoi noise, which is these little patches. Now these are excellent for creating maybe rivers that are running through an environment, or patches of colour shapes and colour breakup and groupings that we spoke about last week in the analysing environments video. So the Voronoi noise does create some very interesting shapes, but it creates them in a straight line. Now we want to break up these straight lines. We can also use Voronoi noise for cracks and such, so we definitely don't want these straight lines if we can help it. So if we drop down another anti-alias noise, plug in the position again, and add that to the position that the Voronoi noise is reading. Drop the frequency some. You can see it starts to affect it, but because we are in world space, an amplitude of 1 is just far too little, so we can boost this up by quite a bit. A little too much. That's a bit better. So I'll take the whole frequency of the Voronoi noise down. And multiply this on top of what we have here. Now, I don't really want it on these areas, perhaps only on the striations. I'll disconnect this by holding down Y and dragging. This gives us this little scissor tool. Drop the multiply in here, plug the subtract back into the multiply, and plug this back in. Cool, so that breaks up these lines here. And I think the last thing I want to do is just to make sure that we aren't affecting the river that you can see here. We'll do this in the same way that we created before by taking the vector to float. I'll just copy and paste that. But taking the position node, the position attribute, and multiplying that on top of all of this. So taking the y-axis, now we're getting some funky values, so I'll drop down a clamp just to make sure we're not going crazy here. And a fit to make sure we're not going crazy here either. There we go. So you can see that that's just removing the rocks from interfering with the river. If we don't like the angles that the rocks are affecting, we can come back to this fit range here and just change these. And there we can tighten them up or loosen them off. So I'll wrap this up here, and next we'll actually use the displace along normal node to affect this geometry.